Great.
So, shall we start, Professor Khattree?
Sure. Yeah.
Okay. Yeah. Namaste to all. It is a great honor to organize the birthday of the statistics legend, Professor C.R. Rao, who is very much there within all of us, and statistics mathematics community celebrates his birthday as if their own birthday and their own kind of a festival for all of them. And I see a lot of enthusiasm all over the world who sent messages on his birthday because of different time zones. Many of us could not join the birthday event. And we are really delighted to have his family attend this talk. Dr. Teja Rao, his daughter, Professor C.R. Rao's daughter, and Mr. Virendra Rao, his son, they took their time to attend today's event. And before I start the event, I want to introduce our speaker, Professor Khattree, in few slides. Ravindra Khattree completed his PhD under the supervision of Dr. C.R. Rao. And he is currently a distinguished professor at Oakland University, USA. And is a professor in the Department of Mathematics and Statistics. And he is co-director, Institute for Data Science, Oakland University, USA. And Khattree is best known in statistics for Fountain-Khattree-Peddada theorem, Khattree-Naik plots, Khattree's non-negative estimators of variance, Khattree-Bahuguna skewness, and many other things. He is very well known in applied statistics and theoretical statistics. And I'm not listing all of them here. And selected awards and recognitions of Professor Khattree. He won Young Researcher Award from International Indian Statistical Association in 2002. And in 2003, he was elected as a Fellow of American Statistical Association. 2008, Oakland University Research Excellence Award. And he has written several textbooks and monographs and edited books. Some of them I'm listing here. In 1999, Khattree, along with Dayanand Naik, they wrote a textbook which is very popular, Applied Multivariate Statistics with SAS software. And in year 2000, he published along with again Naik, Multivariate Data Reduction and Discriminant Analysis with SAS software. And 2003, along with the legend Dr. Rao, Khattree published edited a book titled Statistics in Industry. And 2007, with again Dr. Dayanand Naik. Dr. Naik also PhD student of Dr. Rao, and more about their collaboration, Dr. Khattree going to explain. In 2007, they published another textbook on the title, The Computational Methods in Biomedical Research. And 2025, Khattree edited with his colleague Henry So and myself, Dr. Henry So and myself, the edited book titled Statistics in Industry and Government. With this, I request Professor Khattree to start his talk. Professor Khattree, please.
Sure, thank you. Let me share. Can we share the file?
Yeah.
Okay. Thank you, Professor Rao, for inviting me to give this talk. It is indeed a privilege. Okay. I mean, this couldn't be a better time and better person for whom I should give a talk. I have so much admiration for Professor Rao. So let me just get into this. Obviously, everybody knows Professor Rao. And I will start with a quote from Ashtanga that's actually book on Indian medicine, Ayurveda. And basically there's a quote, relentless pursuit of knowledge and continuous development lead to refinement and excellence. And Professor C.R. Rao is the vivid example of this. He pursued the knowledge relentlessly and basically encouraged others into the path of knowledge. And his developments really need no introduction, although I'm trying to basically talk a little bit about that. Okay. And obviously, he was a refined man, and he is the excellence to the extreme. He passed away 2 years ago on August 22nd at his home in Buffalo. And it's certainly a great loss for all of us. Now, Professor Efron had said once about R.A. Fisher, it's a good rule never to meet your heroes. I could never say that because for me, my hero was my teacher, and I obviously met him. I knew him, well. Okay. And perhaps he was my hero because he was my teacher. So as a PhD student of Rao, his death was certainly lost for me, and obviously he's 2 years now, but still, we feel the loss. Okay, we have not really overcome that shock. I graduated from Pittsburgh, and while at Pittsburgh, I took several courses from him. Okay, so when Professor Arnie Rao asked me to give a memorial talk, I didn't have to think twice about it. It's more than a privilege. It's actually a responsibility and a debt which I owe to my guru. So I thought, what would be a better way to give a talk than to talk about his lifetime work? But obviously, that's perhaps too big a bite to chew. I accepted it when I started preparing a talk. I found it's really a very big undertaking, but one has to try. And he worked for 80 years, and I don't have 80 years of my life to realize the depth of his work. So here I am with a kind of failed attempt, you could say, to summarize his work. So to begin with, I just give a quote from JRSS in 1948. Professor Rao was 27-year-old, and he was invited to give a discussion talk with several discussions by leading experts on his work. And B.L. Welch, who was chairing the session, he said, when Mr. Rao came to this country, and he said Mr. Rao because at that time Rao did not have PhD, about 2 years ago, few of us were aware of the nature and extent of contribution he has made to mathematical statistics. Since then, we have seen accounts of his work appearing regularly in a wide variety of statistics journals, and have come to know to him as a writer who always has something fundamental and interesting to add to the discussion of current problems. It has therefore given the society very great satisfaction that he has been able to address a paper to one of their meetings before his return to India. And we are talking about a 27-year-old young person. Okay. Many of us at 27 did not even know what to do with our life. So much has been written about Professor Rao's personal life and his crucial role about developing ISI. So we'll not talk about that. I'll just concentrate my narrative only to Professor Rao's impact as a researcher and in the process as a nation builder, okay, for India. So I'll attempt to address this commentary, how he has helped develop various research areas within statistics and mathematics. So Efron states, and he's talking about pre-1940 era. In 20th century, when that began, it began on an auspicious statistical note with the appearance of Carl Pearson's famous chi-square paper. The groundwork for statistical growth was laid by eminent people like Neyman, Pearson, Student, Kolomorov, etc., etc. But from our point of view, at the century's end, or at least from my point of view, the dominant figure has been R.F. Fisher. R.F. Fisher's influence is especially pervasive in statistical application, but it also runs through the pages of our theoretical journal. And R.F. Fisher was CRO's advisor. While Fisher may be viewed as father of modern statistics, laying its foundation, it's Rao who has been one of the most influential architects of modern statistics. Only the time will tell, but I feel that in due time, he will be accorded the same status in statistics and data science as we accord to Newton, Cauchy, and Gauss in mathematics and physics. So let's start with first work. And that most of us know, but I think it's important to reiterate on that one. The most well-known and most game-changing work of Rao is his 1945 paper, Information Accuracy Attainable in the Estimation of Statistical Parameter. Okay. And that's essentially has been termed as a classic. And once Professor Rao told me how it came out to be. So he was teaching a course in ISI, and he was 23-year-old, and he was talking about Fisher's efficiency. Fisher's bound on variance of an estimation is essentially a lower bound in the asymptotic sense when sample size goes to infinity. So one of his students, Dandeker, asked him, what about finite sample case? What happens then? And younger Rao did not know the answer, so he said he'll find out. So there wasn't much in the literature except 1921 Fisher's article. So instead of searching so much again in the literature, he went and basically worked on it himself overnight. So next day he has the answer for the class, and that's what is known as Kramer-Rao inequality. And that work culminated into this celebrated article in 1945. Thus, in some ways, this paper was also accidental, but it also takes a person of Rao's caliber to realize the importance of the problem and see the bigger picture to solve a much bigger problem. It's a 13 pages long paper, 8 sections. So you can just imagine each section is 1.5 page on an average. And it has 3 important results, very influential, which change the direction of statistics. And they are Kramer-Rao inequality, which provides a lower bound on the variance of an unbiased estimator, Rao-Blackwell theorem, which provides a way by using the sufficient statistics to improve an unbiased estimator, and then measuring the distance between probability distributions using the differential geometry. That's now known as Fisher-Rao metric. So this is a Kramer-Rao inequality, that variance is always bigger than this bound, 1 over I. Instead of estimating theta, if you are estimating a function of theta, bound can be kind of refined in a more general form. Then Rao-Blackwell theorem, which says if you condition on a sufficient statistic, you can improve on variances. And then distance between the two populations. Two populations represented by 2 points. And if you want to measure distances between the two populations, you measure that as the geodesic distance using the elements of length, basically given here as essentially as summation Gij, theta I, theta j, where Gij is basically defined here. And these are the 3 results in one 13 page long paper. So if you read that paper, it's hard to believe that author must have been 23 or 24-year-old when he had written. It has only 5 references. By page 3, he had proved Kramer inequality. By page 4, he had done Rao-Blackwell theorem. And by page 11, he has introduced differential geometry to define the distances between populations. The mature thinking of the author in his style and authoritative narration leaves no doubt in one's mind that author must have been a genius and that he has really understood the problem to its core. An author repeatedly refers to a 60-page long paper of Fisher, but it conveys much more information in a more succinct form with more clarity in 13 pages. And you can see that the author, C.R. Rao, had not only clear understanding of the problem, but also thorough mastery of multidimensional statistics, matrix theory, differential geometry, and classificatory problems. And the two facts should not escape from our mind. Kramer published his result, Kramer inequality, in 1946, independently he published. And he was a well-established, very senior mathematician by then. David Blackwell, he was very well established and he published in 1947 and he was a professor at University of California, Berkeley. But Rao was in essentially relative isolation because of Second World War. He had no PhD and he was working in a poorly and very self-funded place known as Statistical Laboratory, which now became ISI. And he could still do it on his own. So why is that very important? Because it's influential in introducing numerous subsequent statistical ideas. Kramer inequality provided a yardstick to evaluate the quality of estimation of a parameter. And essentially, if you, for the older people, you will know finding UMVUs was itself a whole industry during 50s and 60s and 70s. And it was Rao's work which essentially defined the subfield, what you called as foundation of statistics or classical statistics. It clarified a lot of ideas of Fisher and showed the importance of sufficiency as a tool in statistical inference. Rao-Blackwell theorem provided a way to construct the optimal estimators. Okay. It brought into light the importance of exponential family for modeling processes, for modeling purposes. And then, of course, geodesic distance as a statistics. It gave rise to the differential geometry and curvature in statistics. And Efron did a lot of work in that area. So there's so much about Kramer inequality that there is a song, and I'm going to skip it, but you can find it on the internet. I think if you want slide, you can have it. So link is given there. But the second and the important topic which Rao introduced was score test. It is one of the 3 most celebrated statistical tests in econometric literature. The other 2 being likelihood ratio test and Neyman-Pearson and Waltz test. All 3 being the first order asymptotically equivalent. But they do differ to some extent in their second order properties. And due to its generality and wide applicability in econometric literature, Rao himself considered this as one of his most useful work. So in short, basically you are testing a hypothesis theta equal to theta 0, and likelihood ratio test, it computes the distance between likelihood at theta hat and at theta 0. While test basically takes the distance as a quadratic form involving information matrix, but score test basically uses the scores and a quadratic form using these scores. And it has interpretation in terms of Lagrangian multiplier in optimizing certain function subject to certain restrictions. And you can really interpret this as a multi-parameter generalization of a locally most powerful test in case of single parameter hypothesis testing. And why it's important? Many tests which were developed subsequently can be viewed as special cases of score test. Chi-square goodness of fit test in linear model, and in the analysis of linear model, it relies on 4 assumptions: correct linear function form, normality of the distribution of the error term, homoscedasticity, equal variance, and serial independence. That means errors are uncorrelated. And these tests are given in the references shown here. And what's important is all these tests can be shown as a special cases of Rao's score test. So he gave test, and that can really accommodate so many other tests which are now a commonplace in uses in applied statistics. Of course, Rao and multivariate analysis cannot be separated. Essentially, a major chunk of multivariate analysis, classical multivariate analysis was developed by C.R. Rao. Okay. And his contributions are evident in his 1945 paper, where he deals with geodesic distances between the populations by representing probability distributions as points on a pair. In the same paper, he also discusses the problems of classification discrimination. Remember the 13 pages long paper. And then in 1960, it's clear that he had long before envisioned the importance of multivariate statistics in scientific data analysis. Over time, multivariate analysis became a discipline of its own, where it became rather impossible to not see Rao's imprints on almost any particular topic. And now, data science, the big data methodology, are to a large extent are multivariate analyses. And in fact, it was to the extent when it was so commonplace that even for us, the students of Rao, it was very difficult to keep track of what results are attributed to Rao and what are done by others. And there are so many popular techniques we use without ever realizing that C.R. Rao had devised them. Okay? And they are so heavily used. And basically, even we made a mistake when we wrote the book. We basically use an F test, and we did not even realize that it was attributed to Rao. And Professor Rao then pointed out by sending a letter here that this is actually called Rao test. And then, as part of multivariate analysis, it's a principal component analysis. The concept of multivariate analysis, MANOVA, multivariate analysis of variance, and associate testing procedures using F-test were developed by Rao, and they have become standard procedure. And his work in multivariate analysis is nicely summarized in recent paper by Diane Smith. Okay, but principal component analysis is another important area developed by Rao. It was introduced by Hotelling long ago, but it was really formalized and given proper interpretation by C.R. Rao in his 1964 paper. And this is really an illuminating paper where Rao provides various interpretations as well as theory of principal component analysis. And then he developed principal component analysis for familial correlations, and that's explained in Konishi and Rao. And today, PCA, principal component analysis, has become a standard data detection tool in any big data analysis. Basically, most of the time, we start with PCA when we have big data. And from hypothesis testing point of view, factor analysis was formalized by him. Okay. And then in multivariate analysis, there's a classificatory problems, what you call as discriminant analysis or supervised learning. This was an area initiated by Fisher, where Rao has written a number of articles. These are too many to refer here. But much of the work formed his doctoral dissertation under the guidance of Fisher. So how did it happen? Mahalanobis was asked by Fisher to send somebody competent to deal with a multitude of anthropological data that was collected by Trevor in Sudan. And who better person could be for this purpose, an expert. So C.R. Rao was sent by Mahalanobis, and there in England, he worked not only on this data, but he also worked in Fisher's laboratory. And all this work culminated in his doctoral dissertation, which obviously he did not need because by that time he was well established and he was presenting discussion papers at JRSS meetings. But that was his dissertation. So in a series of papers coming out of his dissertation, he formalized the classification rules in a framework of Neyman-Pearson lemma with a lot more insight than what the lemma itself just suggests. The problem of classification for more than two populations was comprehensively covered. And then the test of redundancy of variables, what you now call as Rao's U-test, was introduced by him and used in real anthropological data. And what perhaps people do not know, that this is all the time, in those 3 years, he also wrote his first book, Advanced Statistical Methods in Biometric Research. That's an authoritative account of useful techniques for inference on univariate multivariate data till that time. But the book is still relevant today. So this book, when it came, here's a review. Smith says, this is a new book in the famous series of Wiley. It is one of the best books in this series. Indeed, it is one of the best books in statistics available anywhere. And of course, there was some jealousies in certain quarters, as Rao himself once told me. But even today, 70 years since then, a reading of this book is intellectually very stimulating. Okay. It's indeed a worth reading this book even today. And then comes the book. This is the book, Linear Statistical Inference and Applications. Rao published it in 1945. And this was perhaps the first unified account of entire field of mathematical statistics, along with a solid foundation where the latest results known up to that point of time had been incorporated. Even today, this book still illuminates my brain, at least, whenever I read it. But the book is not for uninitiated. Okay? But it has all statistics to learn for a mathematically trained and all mathematical underpinning for an applied statistician to appreciate. So if you are really motivated, you should read this book and you can learn a lot in a very succinct way. And really, it's so succinct. In 78 pages, it basically produces all the matrix algebra that one needs. In next chapter, in 76 pages, all the probability theory it provides. And my personal favorite was the last chapter, where in 89 pages, he presents the techniques of multivariate analysis, for which people have written books and books and books. But it is very succinctly summarized in 89 pages. And then, before he gets into all the discussion, he presents a nice result, which is my personal favorite, and Rao used to call that dropping theorem, which basically says that you can prove the results for multivariate normal by going back to univariate normal and proving it for univariate normal. So it's a very elegant way of doing whole multivariate analysis just by transferring the problem to univariate normal. And that's because of a result by Kramer and Old. And this is something, only person of Rao's caliber would have thought how to really elegantly simplify the tedious derivations, avoid or simplify the tedious derivations of multivariate analysis. In chapters in between, he presents a lot of statistical inference about linear regression, design, and general linear models. But why is the book called Linear Statistical Inference when there's so much in it? And once I asked Rao, and Rao said, well, this is how publisher wanted it, because that time the word linear was fashionable. So perhaps publisher thought it would attract more audience, more readership. But this is what I found in trigonometrics, in the review of this book. And there's a big paragraph, but it just says the first thing to note is that one should not be deterred from using this book by any supposed limitation associated with the word linear. There's much more in that. Okay. And the last line, the amount of detailed information succinctly presented is indeed the outstanding impression from reading this book. A close second is the sensible discussion of applications of theoretically developed methods. So this book had really a lot of impact on how statistics developed in future. Okay. So I'm yet to know a person who complains about the content of the book and having nonlinear things, not just linear. Okay. And actually, Efron once said in one of his videos, when the book came out in 1965, it was a real eye-opener for me. Then it's a linear estimation and matrix theory. In 1954, C.R. Rao undertook a study of analysis of data on the families of survivors of Hiroshima and Nagasaki bombing effects of exposure to the atomic bombs on pregnancy termination in Hiroshima and Nagasaki. So that was published basically as a report. But in the process of computation, he applied generalized inverses. And that got interested in the whole area of generalized inverses. And in the process, he later used it in the unified theory of least square. And then he co-authored, obviously, a book with S.K. Mitra on generalized inverses. And by the way, I worked on that data later in 2010 and 11, okay, when I was at Atomic Bomb Casualty Commission in Japan. So there, the area of linear estimation linear estimation is too vast even to mention here as a key contribution of Rao. But let's just mention that regression, all the tests, etc., many tests for regression models were developed by Rao in 1948 in this paper by Rao and Shah. Concept of estimability, it was introduced by R.C. Bose, but it was clarified, interpreted in an appropriate context by Rao. Analysis of various designs, including block designs, were given by him. Growth curve modeling was formalized by Rao. And in the forthcoming special issue of Sankhya in memory of Rao, we have, and that's basically edited by myself, Dr. Arnie Rao, and Anuradha Rai. There's an exclusive chapter on Rao's contribution on linear estimation by these four authors, and there's a discussion by Thomas Matthew. It's worth reading that really paper and discussion. And these were the only ideas in the context of fixed effect modeling. When it goes random effect modeling in linear model, he went on to develop a lot of other concepts, min-q, quadratic estimation for the variance, and then empirical base estimators of variance constant matrices, and so on. And Rao has written a book with Cleffe on variance component estimation. And then comes to linear algebra and matrix theory. It was basically a child's play for Rao. And when I see his papers, the writing is so elegant and I mean so nice that when you read, you know that it basically you feel that Rao really know in and out of the matrix theory. I have already talked about his interest in generalized inverse, where it is defined as a matrix G so that AG equal to A. But important papers are listed here with the key result, which became crucial in linear model, is basically saying that x prime x times x prime x minus acts as an identity on x prime. Okay. So that's a crucial result in establishing estimability of linear functions. So Rao's alternative definition of generalized inverses, their equivalences, and their implication leave a reader with too much admiration of this work. And then the generalization of control inequality in later years. And that's basically a way to measure the inefficiency of least squares when errors are not independent, they are correlated. Okay. And another area which Rao got interested in the similar context was theory and applications of anti-eigenvalue. And the way it happened that C.R. Rao and Veera, who is present here, wrote a paper titled Stationary Values of the Product of Rayleigh Coefficients. Okay. So I had pointed out to Professor Rao that this parent-offspring correlation based on homologous measurements discussed in this paper is a special case of what is called as smallest anti-eigenvalue. And I made him aware of similar work of mine and others. And basically, based on that, Rao wrote a paper in 2005, Anti-Eigenvalues and Anti-Singular Values of a Matrix and Applications to the Problems in Statistics. So this basically is all in the context of inefficient least square and homologous correlation, etc. How this concept can be used. And then again in matrix theory, another eliminating result pertaining to separation theorem is this result about singular values of matrices and their applications in multivariate analysis. And this result exploits and where these results are exploited to explain the matrix approximation pertaining to predictive analysis. And nowadays, when big data is so hard, these approximations have become an integral part of big data literature. And let's not forget something unusual and unique paper. Usually we use mathematics to prove statistical result, and here is Rao using statistics to prove mathematical results. Okay. So statistical proofs of some matrix inequalities. Okay. It's a must read for any statistician interested in learning about interplay between statistics and mathematics in reverse direction. One should really read this nice paper. And then it's orthogonal array. This is an important topic, which Rao himself thinks is one of the biggest achievements. And really, it is something which has revolutionized the industry. So now in industrial experimentation, the phrase orthogonal array is very familiar. Anybody working in experimentation in industry would know about it. And thanks to Taguchi's approach in 50s and to 90s, okay, and which brought a quality revolution, okay, this became a household name. My own project, which I did in 1980, relies heavily on orthogonal arrays, and I know firsthand how in 70s Indian industries were using orthogonal arrays, how it was being used in Japan, and how it came to be used in USA in 80s and 90s. Orthogonal array has become such a household name in the industry that most people now do not even realize that they were developed by Professor Rao. So this is basically Professor Taguchi with me. And how did that happen? Basically, the way it happened, then after US occupation of Japan, that ended, Taguchi was sent by Japanese government to learn about industrial experimentation. And he was sent to India, to ISI. So Taguchi learned there about orthogonal array, and he started using those techniques in Japan. So basically what he did, he simplified the use of orthogonal arrays by presenting the arrays using graphs, linear graphs. So at the bottom, what you see is the graph. So basically, he presented graphs so that you can assign factors to these nodes, and if the factors have interaction, then they should be joined by an edge. And then accordingly, you can use the array, assign the columns to factors by looking at the graph. So this is a nice intuitive way of basically applying orthogonal array as a design for industrial experimentation. And one can surmise that there would be no successful Taguchi and Taguchi method and no such a big industrial revolution, at least at such a major scale at R&D level and at such an accelerated pace, if there were no orthogonal arrays of C.R. Rao. Okay. I mean, they really played a crucial role, and we don't even realize that how important this concept was in basically bringing the industrial revolution. Then there's an analysis of diversity. Rao himself considers this as one of his main contributions. So in 80s, he got interested in this area and developing an analysis of variance type of partitioning for diversity. So question was, how much diversity among the individuals in a population is due to size and how much due to shape? That was one question. Likewise, also, if a mixture of several populations diverge from each other, we may want to evaluate how much of it is due to diversity between population and how much is within population. So in 1982, he wrote an article where he basically did analysis of diversity. So idea was, you take two individuals from the same population, ith population, and two individuals from jth population, measure these two distances. And then you take one individual from ith population and other from jth population, measure the distances. And then the dissimilarity, you define a dissimilarity between population I and population J is defined as basically Hij distance between two individuals from different population minus average of distance between two individuals in the same population. But obviously, if you want to use this as a measure, it should be non-negative, and that would require that it should be concave. And this paper basically develops a measure using such properties. So Rao, Barbian, Rao and Nayak, they have written important papers, and in biological fields, this has become a commonplace. Okay? It's very much used in biological research. And then there's a characterization of probability distribution. How did Rao ended up working in this area? So in 1943, as part of his master's thesis, C.R. Rao gave a solution to a characterization problem posed by Fish, who basically won a Nobel Prize in economics later on. The problem was that X is related to Z and X star, Y is related to Z and Y star, same Z between the two. So question is, for what distribution does the regression of Y and X linear? So basically X is X star plus Z, Y is Y star plus Z. And for what distribution you have Y and X in such a way the regression of Y on X is linear. And first solution was given by Allen under certain conditions, but then Rao gave a more elegant solution and way less restrictive. Okay, and it was this problem which brought Rao into the area of characterization, and then he published numerous articles on characterization of Poisson, gamma, normal, multivariate normal, and so on. And that resulted in a book, Characterization Problems in Mathematical Statistics, with two Russian authors, Kagan and Linnik. And one of the celebrated theorem of Rao is the Rao-Rubin theorem, which characterizes the Poisson distribution through the damage model. And this result closely aligns with the weighted distribution. That's another important contribution of Rao. Characterization of multivariate normal through distribution of linear combinations played a crucial role, as I mentioned earlier, in proving the distribution properties of multivariate normal and related quantities. And then in later years, Rao worked with Lau and other people and worked on characterization problems involving Cauchy integrated equations and Danish theorem. And with Schanbach, then he wrote a book on this topic. And related to characterization, but on its own right, an area itself was weighted distribution. That's area introduced by C.R. Rao. So in Rao's own word, in a classical paper in 1934, Fisher had demonstrated the need for such an adjustment in specification depending on the way data are ascertained. So basically, extending the idea of Fisher, he introduced the concept of weighted distribution as a method of adjustment applicable to many situations. So what happens sometimes, certain things are unobservable because accident went wrong, something gone bad. So how do I really ascertain the original distribution? So here is basically a picture of Rao where he is introducing weighted distribution, and the problem is that basically the skulls that were collected versus perhaps were only those which were small enough to carry or to store. Large skulls were perhaps destroyed. So basically you couldn't ascertain data on larger part of the population. Okay. So this is the idea, and I'm not going to go through that in the interest of time, but whole idea is fx is defined as some weight times the original density, and then you scale it by dividing by a divisor. And a random variable, it could be a random variable or a random vector, and essentially you define a weighted distribution. And I should say that nowadays people are talking about transmuted distribution and skewed distribution, skew normal distribution, etc. One can see that those are special cases of weighted distributions. And this is our Rao-Rubin theorem, celebrated theorem, which essentially says that Poisson distribution can be characterized by the fact that unconditional distribution for number of items and unconditional distribution number of items under damage or under undamaged remains same, okay, only for Poisson distribution. If Poisson, then this happens. If this happens, distribution has to be Poisson. Okay. And in the context, he defined what he calls as Calcutta blackout distribution. Okay. That is, I think in 1985 or so, he came up with that idea. So let's skip those. But the other area, and very cutting edge area, was statistical signal processing and estimation. And he got interested in 1980 in this area. Two of his students, Nandini Kannan and Devashish Kundu, worked on these problems and wrote their dissertation. And they themselves established themselves as experts in this area. So whole idea was that you got basically a non-linear regression problem, if you may say, or its complex valued version, and you want to study the asymptotic properties. The related issue was model selection, strategies, and Rao worked with Bai and Zhao in those areas. And then the related problem was estimation of the direction of arrival of a signal. We don't know if signal is coming, but we don't know which direction it's coming from. So estimate the direction. Okay, that's a problem of estimation of direction. And another related problem was classifying a signal as one of the several signals. So several signals are being sent. One arrived. We want to know which of these signals was, from which location it came from. So this can be formulated as a problem of classification. And one of the issue at hand was estimation rather than prediction of signal to noise ratio. Okay, and it comes out to the ratio of two quadratic form. And these are highly referred papers. Khattree and Rao's paper is highly referred papers. And then some of the work I did with other colleagues in that area. Okay. And as Kundu says about Rao's contribution, in my opinion, the main contribution of Professor Rao is that he had provided new insights in all these problems, which has helped to bring new ways of solving these and other related problems. And then there was another area, kind of classical area, where Rao's contribution is basically provides a foundation and better understanding of statistics. It's Pitman's measure of nearness. Whole idea was, if I had two estimators of a parameter theta, which one do I choose? And common sense would say, there's a criterion here, choose the one which is closer to theta more than 50% of the time. So clearly, this probability distribution, the expression given here in the middle, this depends on the joint distribution of the two estimators, T1 and T2. And the criterion is not transitive. If T1 is better than T2, in that sense, in the above sense, T2 is better than T3, it doesn't mean T1 is going to be better than T3. Okay. So he did a lot of work. His work drew considerable amount of interest from the likes of P.K. Sen, Malay Ghosh, Jerry Keating, R.L. Mason, Robert Christian, Wang, S.T. Davis, and some of us, the students. Okay. And there's an entire book which came out of this whole work. And his paper was influential, and subsequent work greatly clarified the problematic issue of arbitrarily choosing a criterion for estimation, and illustrated that this may often result in ending up with an estimator which may be inferior if you change the criterion. And Professor Pramod Pathak is here. He has contributed in this work, and he has written, I think, few papers in this area as well. And then there's a selection index and construction. This is an important problem that Rao gave quite a bit of attention in his during 1960s. Objective was to select a fixed proportion of population so as to maximize a function of criterion or response variable. So whole idea was, suppose I want to select best students for a particular job, best workers for a particular job, and I got 5,000 workers. How do I choose, say, 1% of those? So whole idea was, one wanted to select a fixed size part, say 5% or 1% of the population, where the mean of the response variable is maximum. But response variable is unknown for these people because it is to be observed only in future. And the twist was the selection is to be made in stages as more and more predictors become available at various stages. So first time you select 20%. Out of those 20%, you select 10%. So essentially you selected 2%. Okay. That brings several constraints. The problem in relatively simpler form was first proposed and discussed by Professor Rao in 1964. And then Rao realized that this is a complex nonlinear optimization problems. And in various articles, he then dealt with various aspects of this problem. My dissertation was basically in this area. Why is that important? Now, because it has significant influence in other problems. Only later, I realized the seed of the algorithm for that work is now what is known as general missing value imputation. Okay, so missing value imputation, essentially you are trying to basically predict a random variable, and this is what the problem seems like. So Rao considered selection of best specified proportion of multivariate population, and problem was posed as prediction of unobserved missing values for the purpose of construction of an appropriate selection index, involving missing as well as non-missing values. And so really seed of missing value imputation is perhaps in this paper. And equally important is the fact that his approach that he used provides a very innovative application of Neyman-Pearson lemma to an entirely different problem. Okay, that people think of that Neyman-Pearson lemma relevant only in hypothesis testing, but here it's in the selection problem. So in the interest of time, since I want to talk about lasting impact, but I'll perhaps skip it. But if you want, you can have these transparencies. But Professor Rao was a father figure to me. And in academics, we also keep track of our academic genealogy. A person's students are his academic children, and their students are that person's academic children. So once I counted, Professor Rao had 6 generations of academic children, exceeding 600. Okay. In Sanskrit, there is a well-known prayer. I'll translate it. First line means, take me to the path of truth from untruth. And that's really a job of an honest statistician to discover the truth via data and evidence. The second line translates to take me to the light from the darkness. And that's the job of a guru to enlighten those who were blinded to the knowledge. That's us. And the third line amounts to take me from the death to everlasting life via nectar of life. That knowledge indeed is. Nectar of life is essential knowledge. And that's what Professor Rao was. As a statistician, he developed and used statistics to uncover the truth. Even one of his books for general audiences is titled Statistics and Truth. As a teacher and as a researcher, he enlightened his world by creating the new knowledge. And with his place firmly among Gauss, Cauchy, Newman, Leibniz, and the likes, he has defeated the death, and his name will last forever. So as a gratitude to Professor Rao, here's a Sanskrit stanza, and I will translate it. He who removes darkness of ignorance of the blinded, unenlightened, by applying the ointment, the medicine of knowledge, he who opens the eyes, salutation to that guru. So thank you all, and thank you, Professor Rao, for enlightening me in particular, and all of us in statistics who have gone through your work and learned something from it. So thank you all. I think I'll conclude my talk with that. And I'm open to any comments or criticism or questions.
Yeah, thank you, Professor Khattree, for a wonderful talk. Before the end of the session, we'll have vote of thanks formally. And also Professor Rao's family will be invited to say a few words. But before that, let us take questions.
So there are a few pictures while you're waiting up. Yes. Here he's getting basically with Manmohan Singh. Here with George Bush. Here he was getting an honorary degree here at Oakland University. This is with my daughter. He's getting honorary degree. And these are recent academic and non-academic biographies of Rao, obituaries of Rao.
Yeah, several people are, sending messages that, your talk was excellent and everyone enjoying the talk.
Thank you. Thank you. Yeah.
Yeah, before any questions, I have one question, Professor Khattree.
Yeah.
Because you know Professor Rao from 80s and, he has been collaborating with several scientists across the world, and his books are translated into 14 different languages. The textbooks are the major book, Linear Statistical Inference. It is translated into 14 different language beyond other than English.
Right.
Did ever, Professor Rao, thought of, bringing a newer edition after 73, because 1973 was the last edition of this linear statistical inference came. Then the reprints came, but any thoughts about that? Because you are directly attached to him from 80s.
So, okay. So I did ask him this question when he visited me once. I said, why don't you?
You can stop sharing your screen.
Okay. Yeah. So let me stop sharing. Yeah. So I did ask him this question when he visited me once. I said, why don't you revise your book? There's so much has happened since then. And you could, I think there's need generally for a book like, book which has recent advances. And he said, but I don't have time. And he also said, that reading, etc., is kind of little difficult for him.
Okay.
Because, obviously with aging eyes, reading a lot becomes hard. So he perhaps wanted to, but obviously it was the age and he was just too busy with too many other things. It could not be done.
Yeah.
But on that count, just not related to Rao, but we were so much impressed, influenced by Rao, that once me and Shamal Das Pedada, we talked about writing a solution manual to his linear statistical book and solving all the problems. All the
Great.
problems which are given in the book. So provide solutions to those. So we thought that would be a good contribution.
I
But
think that would be still a great contribution if you both finish up the target that.
I know, but we got so busy with our careers because we had to get tenure and all those things. So it
Yeah.
never happened. But as a student, we were contemporaries and we said we should write a solution manual to this book. Yeah, but never happened. So if anybody want to undertake that, that would be a good thing because that book, people read it and some of the problems are difficult to solve. So if somebody can really sit down, has patience and solve all the problems and provide a manual, people will appreciate it. Personally, I will appreciate it.
Correct. In fact, last year, the same Zoom talk on the Professor Rao's birthday was given by Professor Bradley Efron. So in that talk, he was mentioning the same thing. When the second edition came in 1960s, 70s, I know he was a postdoc. Professor Efron was a postdoc, and he was excited along with all his colleagues in statistics department. That's what he mentioned in his talk last year.
Yes, yeah.
And in fact, the obituary written by Anirban Dasgupta in PNAS last year, 2024, after passing away, Professor Anirban Dasgupta, he was mentioning that in his PNAS obituary, that even if Professor Rao has not done any of his research beyond 1945 article, just
Right.
that one book, Linear Statistical Inference, would make him a legend.
Yes, exactly.
That's what Anirban has felt it in his obituary.
Yeah.
Yeah.
Any
And
result you need it's in there, in that book is there. You have to find it. So if you have read that book, I mean, you have learned basically the essence of statistics.
Yeah. And you didn't touch much of his personal life, but because you already had 100 slides about his work. But personality wise, also, we all know, especially when I was in ISI, he comes, so down to earth. ISI treated him, until the last, ISI treated him, Calcutta, like, like a hero welcome. Whenever he used to visit ISI, I saw in the hostels, in the guest houses, the director's office, everywhere, ISI, the workers, the staff, although the staff, they don't understand what is random variable or what is statistics, everyone used to attend Professor Rao's talks.
Yes, yes.
That
Exactly.
was the hero welcome, and the director, all the professors were so respectful to Professor Rao and Mrs. Bhargavi Rao, his wife. And luckily, Professor Rao was taken care so well by his family, his daughter, his son. They are all taken care so well. And myself and Professor Khattree, we both were there in his funeral also. And hundreds of people attended his funeral in Buffalo 2 years ago. So it's a great moment for all of us. And yeah, any question, Professor Patak?
Oh, well, I think I would have liked to see some of his work. Oh, you can't hear me, I suppose. His work in sampling, for example.
Yeah.
Desampling problems. We did some work in that area.
Yeah, he did work in sampling problems. See, I did not talk about sampling, his contribution to ridge regression, bias regression problems. I have not talked about second order efficiency in the interest of time. You had done a lot of work on sampling, and obviously that's influenced by his work. In the context of weighted distribution, application of weighted distribution in the sampling context. No, he has some papers, and the whole idea of weighted distribution basically used in sampling, the probability proportional to size and all those. Yeah.
You're quite right. That's like the Hurwitz-Thompson estimate.
Yeah. Any other
Dr.
question?
Demon has any question? Dr. Suresh Demon?
Oh, yes. I mean, I'm not a statistician, but Professor Rao was the external examiner of my PhD thesis on game theory and applications. So I was really very keen to know that how much he was aware of the game theory, application of game theory, and he referred to John Robinson's question in the one of the seminars at the Cambridge, of the zero-sum game. Why to play this game if everybody gets nothing, zero. So he talked a lot about, and I organized 2 conferences, international conferences in honor of Professor C.R. Rao. And on his 90th birthday, I actually run a blog, and I wrote that the title of the blog was that the C.R. Rao's contribution makes the Nobel Prize irrelevant. And that really prompted Krishna Kumar and H.D. Vinod, we should do something about this C.R. Rao's contribution in the econometrics. And then I think mainly T.K. Krishna Kumar did some paper, and H.D. Vinod did some input, and since the idea was prompted by me, so they also put my name just to acknowledge my contribution. But one question that I want to ask you is that in the course of researching this area, there was some debate between the econometrician like Bera, and also there was an Australian econometrics in the Australia, and there is a Kundu, and Nandini did some paper, and Krishna Kumar, Vinod, and myself did, which was published in the Mathematical Sciences Proceedings, that this guy, Australian econometrician, I forgot, he was the editor of Journal of Econometrics. I can't remember his name right now.
Mhm.
And he was emphasizing that this Rao-Kramer inequality was proved by some statistician in New Zealand using what is called the calculus of variation, and there was some debate about that, but there is not extensive literature available how he did it. And I was wondering if anybody would explore that the calculus of variation result gives the same thing as this Kramer Rao, a lower bound. But nobody actually picked up a synthesis of this. But I came across one time T.K. Raghavan did talk about that one, that there is some results which comes out to be the same. But since I'm not a statistician, I couldn't pursue that matter. I'm more in a game theory rather than that. So do you have any comment about that? Because your focus is mainly on statistical contribution, but Rao's application is in the quantum mechanics, quantum theory, econometrics, and all that stuff, many areas.
Well, Kramer-Rao inequality and basically that has been used, and there's a book on quantum mechanics, basically, where they talk about its use. So basically, the book title itself has Kramer-Rao bound and some applications, quantum mechanics, that kind of thing. So there are applications of those, but obviously I have not gone through other areas other than statistics. So, but Professor Rao was surely very well aware of game theory, and I suppose he knew a lot, although he did not directly work in that area.
But excellent. It was very impressive presentation, Ravi.
Thank you.
And good to see you after a long time, almost for 40 years.
Yes, yeah, good to see you.
Yeah.
Yeah, thank you.
Thank you very much. That was, I mean, of course, I probably understood 0.1% of the talk, but it was very interesting, and thank you for putting it all together.
Thank you. Thank you.
Is this Teja talking? Yeah?
Huh?
Is this Teja?
Yes.
Yeah, I recognize your voice.
But you couldn't recognize my face. I have aged so much.
Yeah,
And we
Teja and Dr.
spend
V.
our time.
Yeah,
I would like to respond slightly to Suresh's comment. There are several applications of Kramer-Rao inequality in other subjects. And there is a professor of physics at University of Arizona. He has written a book on applications of Kramer-Rao inequality to physics, where he actually derived almost all theoretical results in physics using Kramer-Rao inequality.
yeah,
And,
it is Roy Frieden, just to stop.
Dr. Rao himself brought my attention to that when I was helping him to write a proposal for the C.R. Rao Institute in Hyderabad. And also K.R. Pardasarthi had worked on the quantum physics applications of information. And there is quite a bit of work.
Yeah, I mean, Professor Kumar, the person you are mentioning is Roy Frieden, isn't it?
Roy Frieden, right.
Frieden in Arizona.
Yeah. In fact,
he was there in Hyderabad also, Professor Rao's 90th birthday.
Right. Yeah, he was there. And Roy Frieden, in fact, brought my attention to not only that he was trying to encourage me and other economists to do similar thing in economics. And he sent me a few papers on econometrics, where he applied some of the physics ideas to economics. It is something which I don't know whether I have the energy and time to do that, but it is an area which is worth exploring.
Thank you. Yeah. So, Dr. Teja, Mr. Veera, you want to share any words, few words?
Well, thank you so much for, being so persistent and celebrating him at every opportunity you get. Means a lot to us to have him remembered. It's always so well done. And thank you for all of you for being here and, showing your love and care and respect for him.
Of course.
Yeah, you'd have been 105 today.
Correct.
Yeah.
If I may like to take this opportunity. I should call it an economist apology. In the sense, Dr. Rao brought my attention to his paper in Econometrica of 1947, way back in 1962, when he wrote me a letter of recommendation to go to USA to do my PhD at Iowa State University. At that time, I did not really understand his work on characterization much, so I did not pursue that. But that work which he did, if anybody in economics had followed almost immediately, it would have revolutionized econometrics. Econometrics would have taken the original track which was taken by Professor Ragnar Frisch. Ragnar Frisch's concept of econometrics was that there is an economic model of a deterministic system of equations where the variables are all measured with error. And it is for that problem that Frisch posed a question to Neyman in 1936. How to derive a stochastic relationship from deterministic relationships. That question was answered by Dr. Rao in 1947 Econometrica paper. And that route is not taken by any economist after that. I realized this very, very late in life. Actually, when we were celebrating Dr. Rao's birth centenary, I really repented for not taking that route of econometrics. And so I wrote a paper along with Professor B.L.S. Prakash Rao on characterization problem and its applications to econometrics. It is an area, if somebody pursues it further, it would be a great revolution in econometrics.
Thank you, Professor Kumar. Yeah, before I invite Professor Debashish Mandal for a vote of thanks, I have a quick announcement here. One quick announcement. Want to share. So we have a book series. I mean, Springer has just a minute. Excuse me. Springer has initiated a book series. To honor Professor Rao. Oops. Sorry, if not, I'm trying to open up the. Excuse me. Yeah. So this is the new book series 1 year back. Springer has launched, and this is known as Mathematical Marvels, Texts and Monographs in the Spirit of C.R. Rao. And you see that myself, and then the associators are consists of Professor Rao students. Professor Khattree is there, Professor Yahwa, who is there, who is in the audience now. And there are several all over the world. And we want to bring really high-class textbooks and monographs through this series, influenced by Professor Rao's area of research, all the areas of research. And already we have, so far in the 1 year, we are able to accept 4 books in this series. And many proposals are already arriving. And, any of you are interested to write a textbook or monograph, we are not publishing edited books so far in this series. We are only focusing on the monographs and textbooks. And I welcome you all to, anyone interested to publish in this series, or you want, some younger colleague interested to write, feel free to share. This is also available online in the Springer website. And all the books will be published in this series will have a Professor Rao's photo also.
You should do something in your field of work, Rita.
Thank you. So now I invite Professor Debashish Mandal to say vote of thanks. Professor Mandal.
Thank you very much. And I want to thank everyone. Professor Somen Lahiri could not be with us today due to a family emergency. So I have the honor of stepping in on his behalf. First, I would like to thank Professor Arni Srinivasa Rao for organizing this online talk series to celebrate the birth anniversary of Professor C.R. Rao. This is an wonderful way for us to reflect on his life and legacy. I also extend my heartfelt thanks to our speaker, distinguished University Professor Ravindra Khattree, for opening the series with such a thoughtful biographical review of Professor Rao's extraordinary contributions. And it's also wonderful to hear all the thoughtful comments and discussions that followed his talk. Professor Arni Srinivasa Rao asked me to share a few personal reflections about Professor C.R. Rao's and eyesight. So about 28 years ago, around his 77th birthday, Professor C.R. Rao and his wife, Mrs. Bhargavi Rao, visited the ISI hostel, the famous boys hostel, and spent a few hours with us. I had just begun my undergraduate bachelor degree, and it was surreal to hear them share their life stories with such warmth and humility. Around that time, his book, Statistics and Truth, had just come out. And the dinner, the conversation, the whole evening inspired us deeply. A few days later, I bought his classic book, Linear Statistical Inference and its Applications. And that really marked the beginning of my own journey into statistics. Although we did not have the privilege to take his courses or work with him directly, he lived among us through his writings, through the culture of eyesight. I also recall smaller but meaningful encounters. For example, when my mentor, Julian Besag, was elected Fellow of Royal Society, Professor Rao wrote to congratulate him. Julian, in his reply, spoke of how inspiring Professor Rao had been, and added that he was enjoying working with a brilliant statistician from ISI. So these exchanges show just how far Professor C.R. Rao's influence reached among generations, among continents, and across the subfields of statistics. I also feel privileged to have contributed chapters to the handbook series that he edited. In more recent years, my own research has led me back to his seminal ideas, in particularly his work on quadratic entropy and the analysis of diversity. We heard a little bit about that work from Professor Khattree. These ideas remain fresh and influential even today. For me and for many of us, Professor Rao's name, his work, and the ISI itself has given us both an identity and a community. This is perhaps the greatest legacy, that his contribution not just advanced science and our field, but also has inspired generation of young people to see themselves as part of something larger. It's also very special to see Professor Rao's family members here, along with the students and so many fellow statisticians. On behalf of everyone here, I once again thank Professor Khattree for his inspiring talk, Professor Rao's family for joining us, and Professor Arni Srinivasa Rao for his vision in organizing this series. Thank you all.
Thank you.
Thank you. Thank you so much, everyone. And the special issue of Sankhya A and B will be releasing this month and November, 2 issues of A and B, where Professor Rao published out of all the articles, 1/5 of the almost articles Professor Rao published in Sankhya series. He made Sankhya so popular all over the world, and a contribution of Professor Rao in success of Sankhya after founded by Professor Mahalanabi is of very high importance. And as Professor Khattree mentioned, that Sankhya A and B series will be releasing soon. And thank you once again, and we will meet again for next year's Professor Rao's birthday. Thank you. Namaste.
Thank you.
Thank you. Thanks, everyone. Bye.